This PowerPoint presentation is going to be the use of the pounds formula. So math with the pounds formula. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and correct answers to the questions. This is a study guide for treatment math. If this can help you learn, that's great. The state of Florida provides you with a formula sheet when you test. So this is the pounds formula taken off the state of Florida's wastewater treatment formula sheet. So pounds is capacity million gallons times concentration milligrams per liter times 8.34 pounds per gallon. This looks similar. It's pretty much the Davidson pie chart. Question 1. How many pounds of CBOD are entering a wastewater treatment plant per day if the influent CBOD is 215 milligrams per liter and the flow is 1.5 million gallons a day? So you're going to pull out your known, pull out your unknowns. So what we know is 215 milligrams per liter and a flow of 1.5 million gallons a day. What we're looking for is the pounds per day. We're looking for pounds per day, so we're going to use the pounds per day formula. There's a little pie chart over here. We're going to pull out the pounds equals capacity million gallons times concentration milligrams per liter times the standard of 8.34 pounds per gallon. There's it pulled out. So you're going to enter your numbers into your formula. 1.5 million gallons times 215 milligrams per liter times 8.34 pounds per gallon. And that gives you an answer of 2,689.65 pounds. Question 2. How many pounds of nitrogen are leaving a treatment plant if the effluent total nitrogen is 3.5 milligrams per liter and the influent flow is 18 million gallons a day? As always, I like to start with pulling my known and unknowns. So you have 3.5 milligrams per liter, a flow of 18 million gallons per day, and we're looking for pounds. And we use the pounds formula. Pounds is equal to capacity, million gallons, times concentration, milligrams per liter, times 8.34 pounds per gallon. Plug your numbers in. 18 million gallons times 3.5 milligrams per liter times 8.34 pounds per gallon. And your answer is 525.42 pounds. Determine the waste activated sludge pumping rate in gallons per minute if 3,200 pounds a day are to be wasted and the WAS suspended solids concentration is 3,980 milligrams per liter. So we're going to pull out our known and our unknowns. What we know is the 3,200 pounds and 3,980 milligrams per liter. What we're looking for is gallons per minute. So we are using the pounds formula. We're going to have to rearrange it because we're looking for the million gallons. So rearranged, million gallons is pounds divided by the concentration, milligrams per liter, times 8.34 pounds per gallon. Go ahead and plug all that in. 3,200 pounds divided by 3,980 milligrams per liter times 8.34 pounds per gallon. That gives you 0.0964 million gallons a day. We're looking for gallons per minute. So we're going to have to get this into gallons per minute. So you do the 0.0964 times a million divided by 1,440 minutes in a day. And your answer is 66.94 gallons per minute. Determine the waste activated sludge pumping rate in gallons per minute given the following data. The amount of WAS to be wasted is 4,800 pounds per day, and the suspended solid concentration is 4,125 milligrams per liter. So we have our pounds formula. We're going to rearrange it so we can find the million gallons a day. So the pounds will go on top. It'll be divided by the concentration milligrams per liter times 8.34 pounds per gallon. So 4,800 pounds divided by 4,125 milligrams per liter times 8.34 pounds per gallon. That gives you an answer of 0.1395 million gallons a day. And we need to get that into gallons per minute. So you're going to multiply the 0.1395 million gallons a day times a million. This time I went ahead and did there are 24 hours in a day times 60 minutes in an hour, which would give you that 1,440 number we used earlier. So you have 96.87 gallons per minute. What must have been the average influent concentration of suspended solids in milligrams per liter if a wastewater treatment plant's clarifier had a flow of 1,385,000 gallons per day and the clarifier removed 2,270 pounds? As always, I like to pull out the known and the unknowns. So what you know is the flow was 1,385,000 million gallons, 2,270 pounds, and we're looking for milligrams per liter. Again, we're using the pounds formula. We're going to have to rearrange this so that we can solve for milligrams per liter. So rearrange, the concentration of milligrams per liter is equal to the pounds per day divided by the million gallons times 8.34 pounds per gallon. First, we need to get your 1,385,000 gallons into million gallons. So we're going to divide that by a million. We get 1.385 million gallons. We'll plug everything into our formula. So 2,270 pounds per day divided by 1.385 million gallons times 8.34 pounds per gallon. And your answer is 196.5 milligrams per liter. So that was just a quick 5 questions on the pounds formula, and then the pounds formula rearranged to solve for different variables. Hopefully this helps you study. Thanks.